Who's on iPhone?
Professor,
I Yes, Tiara.
when is assignment 4 going to get graded?
This weekend. This weekend.
Okay,
But I was really focused on your projects. Like that was the important piece for me.
okay.
Uh, and then I have projects from other class too, and so they needed those graded as well. So, and since my wife is bedbound for the last 2 weeks, and my kidneys have been not responding to my drug that I have to take, it's been hell on high water with our health situation. So I apologize. This whole semester has been a cluster mess. I'm not gonna cuss because my kids are still awake. Um, yeah, that's a good question. And Tiara, please push me. I don't mind. I don't get frustrated. Like you still haven't graded them. Like
No, it's okay.
I
I
don't
just,
take
I just,
offense.
I just wanted to know because I was trying to calculate my final grade. The whole class is out of 300 points, right?
Yes, it is.
Okay.
Give it, there's flexibility a little bit in like how the grades are. But yeah, so I will be looking at the discussions
Okay.
tomorrow. Who's on iPhone? I need to know who's on iPhone. Otherwise, I have to drop them from the class if I don't have the name. I'm sorry.
Hi, Professor. That's me, Heba. I'm joining from my laptop.
Okay, it says iPhone on it, so you want to change your name. So just so you know,
I
Hiba.
Give me 2 minutes. I'm going to be online from my laptop.
Okay, that's fine. I there's like a
Okay.
confidentiality issue, so I have to be careful.
Okay. Just give me 2 minutes. Okay.
Yeah, you're fine. All right. We have a lot to do today, but a lot of it I don't think it'll be too bad, I hope. But we're gonna have a little fun. Because if you recall at the beginning of the semester when we were meeting, we had opportunities to have discussions about plots, random plots that were observed. And we had to move away from that because I was sick and we had to catch up on stuff. But before we do that, so let me know if you're seeing the slides.
Yep.
Okay. So today we're going to talk about multivariable methods, part two. So before what we were talking about was confounding variables. And we're going to continue that discussion today. So first I want to review project number 3. Okay. The final presentation will be in person, like virtual in person, right? So you don't have to upload a recording. All you're uploading is your final paper, and then we're gonna have the presentation during our finals time. Everyone must ask one question for a presentation. So what I mean by like we're not gonna have 15 questions per presentation. So let's say that Bonita gives her presentation, and then Anant asks a question. That's the one question. Anant does not have to ask any other question. So there'll be one question per presentation from a classmate. Okay, that's related to the project. And then Benito would have to answer the question as best as their ability can be.
Is that within the 6 minutes?
No,
Oh,
it's outside of the 6 minutes. No,
That's
that'd
a
be
good
unfair, right?
question.
That is a really good question. No, that's outside of it. I'll take that peanut butter and jelly, Tiara. Um, it will be starting at 8 p.m. 8 to 9:50 p.m. is the final time. Yeah, that sucks, doesn't it?
hmm
It sucks for you guys. It sucks for me. I'm always stuck with the very last final, but that's what it is. Okay. If you miss the presentation, you will get a 0 for your presentation. There's no makeup. You have to be there for your presentation. The asking of the question is part of the grade. I'm not grading if you asked a good, well, if you ask like, well, where did you get this data? I don't think that's a really relevant question. It's more like, did you think about this? in your analysis, or did you try this analysis? Sorry, there's feedback. Be on time and please practice. I will cut you off at the 6 minutes. We've had experience with this, right? I've cut
Mhm.
you off at the 3. Now you get double time. It's gonna feel like, you know, so much time. The order will start based on last name from the middle of the alphabet. Okay. So we started at based on order of the alphabet from the beginning, at the end, now from the middle. Be on time. It is essential that you be on time for this. Finals week. I will have modified office hours. Mostly it's pretty open. If you need to schedule an appointment, I will schedule an appointment. But to be honest, anything after 6 is really difficult with my wife being very sick and me having to take care of kids. Obviously, I'm scheduled for this, but there was no plan for my wife to be sick. So just to let you know, and then if he's like, can I meet, at 7 p.m. on Thursday, I'm gonna say no, right?
Mhm.
That's like, how's that gonna help? It's not gonna help you, it's not gonna help me. You're gonna get nervous. I'm gonna be freaking out for you, you know. So really plan your time. So you have Monday, Tuesday, Wednesday. You have 3 days to schedule time. But I will block off time in my schedule that says just office hours. And if you want to meet in person, I'll let you know when I'm in on campus. Okay? Because some of you are on campus, and I've met with some of you in person. Questions about project number 3. Please read the document of the expectations.
I
For
read, I read, oh, go ahead, Alex.
for
Yeah, go.
project 3, can we continue to build off like the paper that we used for our last project, or is it a completely different a completely different subject that we're using?
What do you
Same
think?
paper.
We can probably build off the same paper, I would assume.
Yeah, yeah, and what it is I hope you see what the image is been. Not only is it for you to have a better paper and a better presentation, but to build in more data analysis within the paper itself. That has been the goal. Yeah, yeah. But it is still a good question. I'm just teasing you, Alex.
Okay.
Tiara, go ahead.
My question was, when I looked at it, you said that we have to do one confidence interval, one hypothesis testing, or power sampling, or linear regressions, and there's like one other one.
Yeah,
So
we're going
we
to talk
have to,
about the last one today. Those are ORs. So you're going to be doing confidence interval hypothesis testing. Some of you have to clean up what you did before. Some of you, there's a couple of you that have it like just right. And you're like, oh, I don't have to touch that. But then you have to incorporate either the power analysis, linear regression, or the non-parametric test within it. Okay. Most of
okay.
you are probably going to do power analysis, to be honest, because I think a lot of you seem like you understand it. But it's a good question. So you're adding one more component at least. Some of you already like have done some linear regression before and had it in their paper. So, and I gave advice on how to clean that up. Other questions?
Okay, so last question.
You're
You
fine.
said that we lose points if we aren't here for the presentation. How many points is that? How many points is the final project worth?
Final projects were 70. Okay. For the presentation, the rubric, I believe I have it 24 points out of 70 is related to the presentation.
Okay, and then is that including the 5 points for participation too?
No,
Okay.
aka be there. We're there to, and not only that is it's there to support each other, right? And learn from each other. Okay. Other questions? Okay. Just doing something. So let's go. So what we're going to do today is first we're going to go back to this graph, and I'm going to give you a graph. And you're going to work in groups to see what the graph is saying. And I have a link for it. It's a Google Doc. And I want you to think about what is it saying. There's no way anybody's going to get this, but I'm curious. Maybe you will, and you'll surprise me. And then I'll be like, that's impressive. No, no. Sorry. Okay, so let me break up the rooms, but don't join the room yet. Let me give you the link. So you should have access to this Google Doc. So go ahead.
Hey, I didn't even click on a link to the graph.
1999. Hello, everyone.
Hey, Yana.
2020. As a side note, Tierra, Ivory, and me, we need to get together and tackle maternal and infant mortality
Yeah, I know, right?
as a team, okay?
Yeah, but I think you should graduate next semester. I still got a long ways to
Yeah,
go.
in 10 days, I'm graduating in 10 days.
Oh,
After that, we
oh, in
can
10
tackle
days?
it together as a team.
Yeah.
Congratulations.
Oh, thank you. Thank you so much.
Yeah.
Let's see, 1999 to 2020. This graph is all over the place. Is that big square rectangle supposed to mean something?
That's where
The answer, the legend?
the legend.
Okay.
That's where the real stuff is.
Well, we know something happened in 2013-ish, right? That decreased all of this stuff. Something happened in 2013 and everybody was decreasing, and then it went back up-ish again.
Can you share the link with me so I can click on it? Because I didn't click on it before I left the breakout room.
Can you what?
You'll click on it because I didn't click on the link before. I mean, can you send it to me because I didn't click on the
Oh,
link
okay,
before?
gotcha.
Oh, never mind.
I just sent it to you. It looks
I
like
got
it's
it.
still on there.
Yeah.
What do you think?
Hmm.
I have no idea. Yeah.
No, I don't have it. It just
Did something happen in 2013? Do you guys recall anything happening in 2013?
mm-mm.
2013, I don't know. There's one, two, three, four, five, six groups.
It's 6 groups, so would it be like race and ethnic groups? Something between race and ethnic groups?
Hmm, maybe. And then the on the y axis is only up to 70.
Maybe that's age.
Age, age. What happened in
What?
2013?
Oh,
I don't
I don't know.
recall. Let me see.
Maybe it's something with age
It says
and
Affordable Care Act was implemented in Information's all over the place. But I'm leaning towards age for that y-axis. Okay, affordable.
I feel like it's gonna be something that we like least expect.
It says 2014 enough. So that's still kind of 2014. So then
Maybe it's
is that age or something for a million or something 50,000? 50.
maybe it's like vaccination records between different ethnic groups or um, mm, I was about to say the H1N1 flu, but that was like 2009.
Yeah.
I think it's I don't know. I wish I knew what it was.
I would like for somebody in your group to be your a speaker for what you think this graph represents.
We said okay, but we said age and ethnic groups and the Affordable Care Act.
Okay. Okay.
Do you think
You got
something
us
else?
on this one.
Ivory and Ananth, do you all agree? Disagree? I think they're full of baloney.
Yeah, that's what we decided.
Ooh,
Give us a hint.
interesting. No, there's no hint. That's the fun part about this. This is the game. Okay, so make sure you have a speaker. I'm gonna close the breakout rooms in a minute.
I guess I could sum it up for us.
Go ahead.
I guess I could sum it up. Did we decide what each of the 6 groups mean?
Race and ethnic group.
Race and ethnic group, yeah.
Race and ethnic groups, yeah. White, Black, Asian, Hispanic. Wait,
Black.
average
White,
age.
Black,
White.
Asian.
Okay.
Pacific Islander. Pacific Islander. Yeah.
Indigenous. But so age is what we're seeing on the y-axis. The age. Oh, the age at which each ethnic group obtain health insurance. The age. So
Yeah.
maybe the top one, maybe the bottom one is white. The age, so whites are younger when they obtain health insurance.
Or can you maybe life insurance too? But never mind. I forgot we doing the Affordable Care Act. I was about to say life insurance. I forgot we doing the Affordable Care Act. Yeah.
And they weren't that impacted by the Affordable Care Act, like whether or not how young or old they obtained health insurance.
Yeah, because I can't think of any other major events that took place in 2013 either.
No.
Let
me check.
I don't think so.
Google to see if Google can tell us anything else about major events in 2013.
Maybe that's when minimum wage went up.
All right, I think everybody's back. Okay, Zahra. Yeah. All right, we'll go with Uzman's group because I think they already voluntold him that he is doing this for that group. So go ahead, Uzman. What'd your group think it was?
So we actually couldn't figure out exactly what this is about. But the one thing that we have noticed that over the period of time, like from 1999 till 2020, they are actually and on the other side, vertical side, they have divided it into ages, and like 50 years of people, like 50 years age group people and 30-year age group people, that they have like different groups, and they have either like analyze about something like income or uh, we actually couldn't figure out what exactly it is for, but they're divided into different groups, and or and they're like with the fluctuations in like at the age of 50, it rose up to 60, and then over the period of time like something like that.
Okay. Yeah. Okay. Good.
Yeah.
Um, group two, I think, was Ivory, Yana, Tiara, and I forget who else was in your group.
Nonce.
Oh yeah, thank you. So who's your speaker?
I will speak on behalf of my team. So we decided that in 2013, 2014, the Affordable Care Act was implemented. And so we decided the y-axis is average age. And each of those groups represent an ethnic or racial group. And so from 1999 to 2013, it explains the average age at which those racial groups obtain their health insurance. So after 2013, that started to increase again.
Okay. And what are the two top to racial groups?
We decided on black, white. Anand, what was the one that you had mentioned? Indigenous group,
Okay.
Hispanic, Asian.
Okay.
Yes, and that's our conclusion.
Cool. All right. Chelsea, I think Heba was in your group. Um, who else was
Yeah,
in your group?
yeah, we were group three.
Samaya.
So,
Yeah.
yeah, so we decided that the x-axis is a 20-year trend, and then the y-axis are different age groups. And we basically said that the lines on the graph, they represent like reoccurring health conditions. So maybe like diabetes and things that are happening in like these different age groups.
Mm-hmm.
Oh, interesting. That is really that's okay. It was good. So one of the things, the reason I like to do this, and the reason I miss that we weren't doing it in the middle of the semester, is it gives us into a habit of making sure that we label things well, right?
Mm-hmm.
And that we get practice of trying to explain a graph, even if we don't have all the information. And people do this all the time. They manipulate it. Okay, you're not gonna believe it. This was just published less than a month ago. Let me get a full screen. I'll share. This is what it is. Mortality rate for 100,000 individuals for youth between ages 1 to 19.
Holy,
It's depressing.
yeah.
Yeah. Wow.
You were
Wow.
right. I think most people were right that it was like based off ethnic group along the lines.
Mhm.
Actually, I like the last group that was talking about like different types of diseases. That actually would have been a cool way to present the data. I'll give you a second to read it and see what are you noticing?
American Indians and Alaska Natives always health outcomes seem so abhorrent and like not even like aggressively worse than other groups.
Yeah. I mean, it's
Wow.
basically black and American Indians usually have
Mm-hmm.
get the short end of the stick in a lot of this.
In some articles that I've read, there's a high rate of suicide
Mm.
in Alaskan Indian population and like death by liver cirrhosis in that population as well, I believe. This is
Yeah,
some
alcohol
articles I read
consumption.
some time ago though.
Yeah. I'm surprised Latinos have lower rates than whites.
Yeah.
Also, like Asian or Pacific Islander,
Yeah.
they have like early mortality rate, if I'm not wrong.
Hmm. Yeah.
Mm-hmm.
Then it also makes me question because um, for the Asian population, how much information was gathered for each of those groups to be able to say
Mhm.
that each of those mortality rates are accurate.
Yeah.
Yeah, not only that is like the Asian population's huge, right? You have
Right, yeah.
indigenous Asian population in Pacific Islanders very different than mainland Chinese population that have immigrated to the United States,
Hmm.
or ones that have been here for many generations.
Or even
So
like the Hmong or like Cambodian. Yeah.
exactly. So that's a huge population, but it's also similar with Hispanics, right? If I'm Hispanic
Yeah.
and from Mexico, it's very different than if I'm Hispanic and from Bolivia.
Yeah.
Sir,
So, but we
um,
don't have a choice. We have to cluster it somehow. Yeah, Uzman, what were you gonna say? Go
yeah.
ahead.
So, what are those bold dots in the middle of that? What do that represents? You have
So
any?
they're trying to represent like abrupt change. So they noticed that in 2002 there was an abrupt increase here
Oh,
for Native Americans, and then in 2010 there's an abrupt. It was decreasing, but an abrupt decrease. So
oh.
what's happening is the slope changing pretty quickly. And in the paper they talk about like why that's happening a little bit. So here that abrupt decrease stopped in
Mm-hmm.
2013, right? And everybody's talking about the Affordable Care Act. I didn't even think about that in 2013. That was like a good, but then it started to increase again. So, and you see that with the black population too in 2014, it
Mm-hmm.
started to increase again. So, that's what these dots represent is where they're starting to see sharp changes, and they talk about it then further in the paper.
Okay.
Okay. It just, I thought you would all appreciate it. Um, it might have been just, hold on. It might have been published less than a month ago. So a recent article. By the way, notice what you're seeing at the uptick in 2019 and 2020. Are we surprised? No.
A little.
Mm-mm.
COVID or
Oh, why? Yes, please. I wasn't, but I'm curious if others were. Yes, go ahead.
Because of COVID, right? And like access to um like testing and basic like PPE, I assume. Like, is that a big part of it?
That's what I was thinking. I was thinking more about home situations, but go ahead, Benita. Why are you little? And there's not a right answer to this.
Well, so I didn't even factor in COVID, but like I'm thinking, if COVID is a factor, aside from COVID, is there anything else, or is there like a huge contributor as to why there is such a staggering, I guess, increase between that period of time?
Yeah, and I think that's when you have to dive into the data, right?
Mhm.
Okay.
Yeah. Yeah, go ahead, Zara.
Yeah, I was thinking, it is a little surprising because like we did go on lockdown, and we were
Yeah.
at home and so like people should have been like less susceptible to, I know there was way less traffic, like less susceptible to other things in life that would probably cause death, but I don't
Mhm.
know.
But I think one of the leading indicators might be suicide or
Yeah.
trying to and if I'm in a family, if I'm
Wow.
homosexual and in a family that doesn't approve of me and now I'm isolated and I have to be locked at home. There's a lot of mental health
Mhm.
issues there that might be involved.
Mhm.
I'm using an example, but that was like one of my biggest fears, for kids because sometimes the safe haven is at school. So yeah, but yeah, you bring up a good point. We have to dive into the data. Other questions about this? Look at data, look at the graphs. I hope you get one little iota from this course is to understand that looking at graphs and spending time reading them is very valuable.
Hmm.
All right.
Just
Oh yeah,
out of
Yana. Yeah, go ahead, please.
Yeah. For this, you mentioned to me when I did my one of the graphs that I used in my project, you suggested that I use a bar graph instead of a line graph. Um,
Yeah.
is there like a rule of thumb when you would use one over the other? Because I feel that I'm just gonna arbitrarily choose which one looks good and represents the data that I want to represent.
Yeah,
Um,
my recommendation is I use a line graph when I'm looking over an extended period of time and I'm looking for a trend.
gotcha,
A bar graph is more like comparison of groups.
gotcha.
That's how I do it. Yeah, but sometimes the line might look good. It's like, oh, this might be telling my story. But typically line graphs like this are used for time. Okay. Yeah, this is a good question. All right, last time we did confounding and modification effect. Um, One of the things that was important when we were doing these examples, we had to be detailed. And even more important, we had to do two hypothesis testing. And we did a really extensive example that we spent a minutes amount of time where we were looking at if ADHD and exposure to lead, right, were related. And we said, well, maybe we know that the father's ADHD might affect the ability to be exposed to lead and the child also having ADHD. So that was that confounding variable. And so we did this example. This time, what we're going to do is we're going to do a little bit of linear regression. And to do this, I'm going to start with a very stupid, simple example. It's not stupid, but it's one that I came up with. Just throwing weight and height based off of age. So I have this nice little table. Okay. And I have the age of this child of children from 1 to 8, and I have their average weight and average height. And this data was like estimated, just kind of gathered randomly. To be honest, I chose numbers that are going to look pretty for us. This is actually not what happens because if anybody has children, they know that they plateau and then they skyrocket, plateau and skyrocket, right? All the time. And they'll eat you out of house and home right before they're skyrocketing. So, but whatever, this works. So what we want to do is we're going to do a scatter plot. And you can do this in R. You can do this in Excel. We're going to do it in R together just because it's easier. I say in groups, but I think based on time and everybody's tired, they just want to get through some material. Um, we'll kind of talk about it. But what I'd like you to do is if you have R or if you have Excel, you can pull up it on your computer and you can type in this and figure out how you would do a scatter plot. And some of you have done it actually for your projects. Oops. And here, I'll share my Excel file. I'll share this like this. I get to cheat. I get to copy and paste. Actually, I'll put it in the chat too, so if you want to cheat. Let me know if I can move on. Once you're done, give me a thumbs up. You can do. Got two of you. Okay, 3, Samaya. I gotcha. All right, we got Ananth, Samaya, Zahara. Anybody else got it done? Don't wait for me. Okay, it's totally fine. Anybody else? Eba, Zubia, Alex, Marcella, Ivory, Anna, Tiara, Bonita. Alex, gotcha. It's okay. I don't want to rush you too much. Chelsea. Oh, you got it. Okay.
I had to log into my email because they had logged me out. I'm doing it now.
Okay. Yeah, no problem. Marcella, you got it. Good. Yana, did you get it?
I am slowly working on it. My computer has very limited space, so I'm not able to use two different things at the same time.
Okay,
So I'm
no, that's
working
fine.
on
That's
it.
fine. That's fine. This is the disadvantage. The big disadvantage of this class being virtual is we can't spend a good amount of time doing like calculations like this. It sucks. It really sucks. Ivory, you got it? Do you have it? Eva?
It's still working.
Okay. Yeah, it's okay. I just need responses. I just Zubia, do you have it? Ah, yes. Perfect. Perfect timing. Bonita?
Still working on it.
Okay, yeah. I just want to make sure. I want could trust me. Just get the data first, and then you're gonna see it's very. All right, Yana's got it. No problem. Ivory?
Yeah, I got it. At first, I was getting an error. I guess I was putting it in wrong, but now it's
Hmm.
working.
Yeah, I mean, we're gonna get errors. That's we learn from them, right? Errors are good things. Eva, yay!
Dr. Hibden, I think I got it, but as far as the age goes, so that's from age 1 to 8, or that's
Yeah.
just number 1 to 8?
Yeah, we don't have to worry about it at the moment.
Okay. Okay.
Yeah.
I got it.
Okay. Who's left? Who are we missing? Tiara? Yeah, I'll wait a second, okay? Since you had login issues. We're waiting for our colleagues. Other questions about the class? Oh, you should be asking yourself, how many people have filled out the survey for the class to get extra credit? Right? Remember that goes to extra credit for the course? And we need what number? How many people?
I don't recall.
I did it.
You don't have to tell me you did it. You don't tell me you did it because it's anonymous. I'll never see. I'll never see who did
Oh
it or
no,
didn't.
I'm done. I'm done. I'm done.
Oh. Okay. So just as a reminder, don't forget to do a course evaluation. Sorry, too. Sorry, it's my bad. For the extra credit, we needed 13 of 15 people to do it. Okay. So far, we only have 5. It has to be done by Monday. Okay. I don't know what they are for public health. I always forget what they look like. I don't know if they're long or short. Zahra, do it. Yes. Okay. So just get it done. Okay. Let's move on. Me share R. So this is what it should look like if you're doing it in R. And what do you think the command is to get a scatter plot? What do you think it is to get a plot?
Scat plot.
That's a good guess. Do you want to know what it is? It's plot.
Mm.
Okay. We do that, and the way my screen is built is it doesn't look great. So let's do this. So what do you think about that data? What do you think this is telling us? Go ahead, Yana.
It's about right.
What?
So it's about right. It looks similar. It looks very familiar.
Notice we didn't really care about age here. And that was brought up, I think Bonita was asking about that.
Okay. Thank you for clarifying.
Yeah, all we're curious is like as your weight increases, your height is increasing as the child, right? And we're talking about children. It should be the other way around, height versus weight. And we can do that. We can just say, okay, well, I want to do plot, height as a function of weight. Okay. And it'll switch it. And it doesn't matter which way, as long as you're telling the story. The reason I think when I'm talking about 8-year-olds is really their weight precedes their height growth. So they will increase their weight first, and then they get a growth spurt. So that's why I had the data switch like this. So as their weight increases, their height is increasing. What's the problem with this graph? If I printed off this graph, what is the issue you already have with it?
The number scale is like all wonky.
Yeah, explain. Go a little bit further.
Like it starts at 30 and 20 respectively, and it doesn't really like show you the full progression from 0 to like whatever you want your max value to be.
Yeah, I agree. Typically, we can avoid that. We can. That's okay. And the reason is we don't necessarily need to go from 0 to a number, 0 to something. But yeah, that could be one thing, and we can change the scale. What's another issue? I agree, Alex.
I would add grid lines to
Mhm.
it makes it easier to find like
Okay.
the coordinates?
Yeah. Yeah. It helps, right? It helps with the visualization. Anything else?
I don't know. It's not labeled like 20 what,
20
30
and what?
what.
Yeah, units, right?
Hmm.
So let's do this. And I provide this. So what we're gonna do is do weight, height. I'm gonna give a title. That's what this right here is. We're gonna label it as weight, capitalize it, and pounds, height in inches, and we'll the PCH just tells you the scale of the pixels. So what it's done now is it's filled them in, and you can add the grid lines and all that stuff. Look how much nicer this is.
Professor, when I did math, I included age too, so I had got height and weight on my graph,
Hmm.
and I did the age too, so I got the age at the bottom.
Oh yeah, yeah. So that's why we can ignore that. Um, and what that's doing is it's categorizing each of those values as different age categories. It's trying to do a three-dimensional graph.
Hmm.
Yeah. And avoid 3D graphs at all cost. Even mathematicians avoid 3D graphs.
Why?
Our brain has a really hard time conceptualizing from two-dimensional to three-dimensional. So when you see an image that's looks like it's 3D on a flat piece of paper or on a screen, it is difficult for us to visualize. Okay. And remember, our job is not to confuse the audience. But look how much better this is. We want to make sure we're clear about the units. We want to have this nice little title a little bit. Okay. Now, what do you think about this line or what this graph? Well, I gave it away. What does it look like? What do you summarize or what would you say about this data?
I feel like the height and weight is like increasing very linearly, going
Yeah.
upward.
Hmm.
Yeah, it looks pretty linear, right?
Consistent. Yeah.
Pretty consistent. Okay. So that's what we're going to study here. That's what we're going to review here. We will take a break here in 5 minutes, but I want to get back to our slides. So what's happening is it appears that the data has this kind of linear relationship. And our goal is how linear is it? So you have an upward trend, which implies a positive association, not causation, but association between height and weight. As height increases, weight increases. A line that approximates data is called a least squares line or a fitted regression line. Has anybody heard of linear regression?
I've heard of it, but I have no idea what it means.
And that's what we're here for. And the question really is how positive is the data, right?
Mhm.
How linear is the data? Does everything fall perfectly on the line? That's telling us something. Or is it clustered around the line, but it's still an upward trend? Imagine that you get 10 children and you measure their height and weight for the next 8 years and you put it up, right? Is all of it really tightly clustered or is it kind of a box? It's like a jumble of data. So if you see this little example in this image here, we want to understand if we have this positive correlation, no correlation, or negative correlation for the height and weight. And our goal is, can we calculate, and you might have seen the R value, and we're going to talk about what that R value is. Okay. I want to recall that the way this is done, and we're not going to do this here because of time, and I don't want you to worry about the calculations, that we did a t-test to calculate the z-scores or standardized data so that the mean was 0 and the standard deviation is 1. We're going to be doing that, but we're going to actually be doing that for two different variables here. Before you were just doing for average. Here you're doing it for two averages, height and weight. We won't worry about how you do it in R, but if you did it, it would look like this. Okay. And what we notice is, notice if I take a line here and I go a line between that's from 0 and 0, so like your Cartesian coordinate systems, X and Y axes, the data is split where most of the data is either in the positive domain or in the negative domain. Okay. And if this is true, what this tells us is we have what's known as a positive correlation. By the way, negative times negative is a positive, isn't it? So that's why we call this positive. This is positive. Don't worry about the calculations here. I give it because I'm a mathematician. I can't help myself. I'm sorry. But every software out there will calculate the R value for us. Excel does this the best. Since all points are in the positive domain, we expect a positive correlation. The correlation coefficient, this R value, is the sum of this relationship. Okay. But all it really is saying is that R tells us how positive is it? How much like a line is the data? The correlation coefficient for our data in R, and I did the actual calculation here in red, is almost exactly 1. And you say, is that good, bad? What is that? Like, how am I supposed to interpret it?
Isn't it supposed to be closer to 1?
Yeah, that's right. The value can be either from -1 to 1. And the closer to 1 it is, the more positive correlation we have. And this is really close to 1, but it's also me generating the data. So if R is positive, positive correlation. If R is negative, negative correlation. The closer it is to +1 or -1, the stronger the correlation. So think about it is like this, the closer I get to being on these lines, these X, this Y equals X or Y equals minus X lines, the better the correlation is. All right. This is a rough, but I want to make sure that you're exposed to this because you will see this in data. People will present scatter plots of a bunch of different points, and then they'll draw a line through it and say this is a positive correlation. And they'll give some value for R. They'll say R is 0.23. Yeah, it's positive. But is that real? Is it strongly positive?
Hmm.
Or is it just random?
Mhm.
I mean, that is always the question. Your job is to be skeptical of the data that's being presented. All right, let's take a 5-minute break. Be back here at
Professor, I have a
7:11.
question.
Yes, please, Siba.
Okay, so it should be like below 1, or it can go above 1 also.
No, it can never go above 1.
Mm.
If somebody
Okay.
says the R value is 1.2, they're wrong. It's impossible.
And that's like the ideal number, like 1.2, you said.
1
It
is
should
the
be like
ideal number.
1. Okay.
It's like
But
super positive.
yeah, it will never be
Okay.
1. Real life, it will never be 1. If somebody says the R value is 1, I am questioning that data to the day I die. There is no way the R value is 1. I generated this data to make it as close to 1 as possible,
Mhm.
right? And this is me self-selecting. It was also based on observation with my kids and stuff. Okay. Other questions? All right. All right. Back. Let's say 7:12. Take your break. All right. Welcome back, everyone. So what we've done so far is we kind of talked about this correlation and what it is basically representing. So positive, again, I want to reiterate, is as one variable changes, the other one will increases. As one variable increases, the other one will increase. That's what positive means. Negative means as one increases, the other decreases. Okay. So a good example of negative correlation is the amount of sleep I get in the day, right? As that decreases, my irritation increases. I mean, you know, there's many different examples, but that's just something fun. Again, to calculate this R value, I want to reiterate something that's really important. Remember, these are sample sizes. You're working within a sample. And so you're trying to basically say R is a sample correlation, and you want to relate that to the population correlation row. Okay. Remember, that's all we've been doing, right? Is sample, and how does that relate to the larger population? One of the most important things is we're assuming that X and Y values are selected at random. It's not required, but at least one of these have to be random. And again, you can calculate this R value by using this command correlation R. So it's COR. Okay. You'll get the same value if you do it as calculated by hand. But again, in Excel, it does it automatically if you add a trend line. So what's happening is this is called bivariate random sampling modeling. And what we're doing, we have a huge population and you're taking data from that population, right? That's what the sampling means. But it's bivariate, so it means there's two values. Bi is two, variables are variate. Okay. And then we're going to observe that these the averages, right, from the sample are given as normal, and our standard deviation for those samples are given as the following. These are, again, estimates for the real population. I want to keep reiterating this, and this is very important. All the data that you see from your papers and that you're analyzing is usually trying to estimate what it is for the larger population. 95% confidence interval that you've obtained is saying that the whole population would fall within, we believe 95% confidence the whole population falls in that domain or that range. When we do hypothesis testing, we're 95% confident that this is what would happen every time. Okay. Something of note is not always does R represent population correlation. It could represent other types of correlation, just so you know. So one of the things is, well, can we do some kind of inference from this? Inference, recall, means is a hypothesis test. So how well does our calculated R value match with what we believe would be the population R value? So we do the same process. It's a hypothesis test. We have this multiple step example. We state the null, calculate the test statistic, get the degrees of freedom, calculate the p-value, and compare to alpha, and then state the conclusion. It's the same process. All hypothesis tests follow the same procedure. But the difference here is the null hypothesis states that there is no correlation. And we said we have positive correlation when it was close to 1, negative correlation when it's close to -1. So if there's no correlation, it's close to 0. The test statistic is given by this relationship. Okay. It's probably the easiest test statistic to calculate because you know what the R value is for your data, you know what your sample size is, and you know what the R value is. Degrees of freedom is -2. Why do you think it's -2? Any thoughts?
But it's a bivariate.
Yeah, it's bivariate. Very good, Alex. Yeah, you have an X and a Y. And then we get the p-value from the student's t-distribution. Okay, that's very important too. So, so from our data, what we would be doing is saying there's no correlation between weight and height of the child age. We obviously know that's not true, but let's test it if that's true for the larger set. We can calculate the t-value, right? And we get 42. The degrees of freedom is 6. And we get the p-value from the table. There's a table for this in the back of the book, and I will give you the page number. Like in particular to get this to. Sorry, I had it written in my notes, but I know it's wrong. Okay. So our degrees of freedom is 6, and we know that value is going to be very, very, very small. And so it's that from the t-distribution, the student's t-test. Okay, and that's on table 2. I wanted to look something up quickly. I'm going to provide something else. Okay. So we reject the null. So the data provides sufficient evidence that the height and weight of children age 1 to 8 is linear related, which makes sense. We know that's true. Now, what can we get a 95% confidence interval? So we can do a t-test. And I want to note that this only works if the value of p is going to be bigger than value of rho is bigger than 0. Okay, much bigger than 0. This transformation is known as a Fisher transformation of R. And I don't think it's too important, the formula here. But I want to note really nice is when we work with this is that it allows us to get some range of values of what we expect the R value to be. Okay. So we want a 95% confidence interval for rho with R given and N is 40. And here, just give an example. I'm not going to go through it in detail because I'm not asking too much of you from this type, but I want you to be exposed to it. It's really important you understand some linear regression analysis. The question is, this is in Z, right? We wanted to get back into rho. What do you think we're going to have to do? This is not rho. What do you think we're going to have to do? Because remember, you want the interval for rho. This is ZR. So ZR is here. So we took R and we transformed it into using a Fisher transformation into ZR. And then we calculated a confidence interval. That's not what we want. We really want it in for rho. Thoughts?
No, I don't have any thoughts.
Okay,
Just
that's a
prayer.
legit answer. But remember, what we did was we went from R to ZR, right? We did a bunch of stuff to get this confidence interval here, but it's for ZR. So we're probably gonna have to go which way? You went forward. Now we're gonna have to go
Backwards.
exactly.
Convert back.
Yeah. Again, to do that, we have to solve this relationship. This is why I don't give homework related to this, because this is something that we do in our upper level math courses. But I want you to see where it's coming from. And so what we say is that we have a 95% confidence interval that the population's correlation would be in this range. Notice it's still positive, so we're still gonna have a positive correlation. So what does that mean? We have the ability to get an R value, right? Talk about how linear is the data. We have the ability to get a hypothesis test to say how closely related is it to the population itself. And only that we have the ability to give a range of what that R value should be within some 95% confidence. And this is what we've been doing data for averages and for proportions. Now we can even do that for a line, for a bunch of scattered data. What we've been doing is calculating a correlation coefficient. Correlation does not mean causation. I want to reiterate, correlation does not mean causation. Height, an increase in weight does not mean an increase in height. If that was true, I'd be 7'5". Okay? That was meant as a joke, but nobody laughed, so I will take that. And I think that's very, very, very important. Oh, thanks, Yana. I'll take. Oh, yes. Do not confuse the two. So many people do this all the time. They will say they'll see a graph of as ice cream sales increase, and we see crime rate increase. Are you telling me ice cream sales cause crime increase? No, that's baloney. Okay. What that's really saying is there's a correlation, not a causation. One doesn't cause the other. What it could be is more kids are out of school during the summer when you eat more ice cream, and more of those kids are out of school without adult supervision. Yeah, temperature. We know this in Chicago. This is like a well-known fact. When the summers are hot and it's in the, we have a 3-day weekend, we see more ice cream sales, but we're also going to see more crime. Yeah. But people do this all the time with data. There, a very complex way to show causation. It is very complex. The other thing is outliers affect the results. If I have two or three people that are children that are malnourished, then the concept of that having that linear correlation of R being almost one will decrease. But those are outliers, hopefully.
I
I
like
just really,
Outliers by Malcolm Gladwell. That's a good book.
yeah, I actually highly recommend that for a lot of people is to read that book. Uh, yeah, that's a great recommendation. Is it's fun. It's a fun read. Yeah, thank you. That's a really good recommendation. So where is this coming from? So I want to reiterate that this is an equation of a line. So recall that we have our point slope, our y equals mx plus b for slope intercept. And this is where this is all coming from. Oh yes, Benita, please, you can interrupt. You don't have to raise your hand.
I'm sorry. So going back to causation, and causation does not mean correlation or the other way around. However, that
Correlation
was
does not
worded.
mean causation.
Yeah. Okay. So is there ever a hard causation to anything? Because it sounds
Yeah,
like
yes.
okay.
We
Okay.
have abilities to test that. But a lot of
Okay.
times people will give you this plot. Like this, or here, I'll give the original. Right? Let's say that's not weight and height, but that's age and income, right?
Mhm.
And you're saying as your age increases, your income increases. Yeah, there typically there's a correlation there, but doesn't mean that age is causing income to increase.
Professor, I was driving in the car with my husband on the radio. They said like Black women are more likely to get C-sections at a Pacific hospital, and they noticed that it was a correlation to them being operated on when the operating room was available compared to white women being operated on when it was a room available. When it wasn't any rooms available, Black women didn't get C-sections.
Yeah, and notice they use the word correlation, right? Not causation.
Yeah.
That's a key word. The person reporting that is very good. Whoever reported that or whoever wrote the article, very good. We can't say it's a cause. It's a whole different issue. That's a whole different can that you have to be careful of even saying.
Yes, but even going back to the age and the weight, I mean that could
Item.
also be a a, a correlation and not necessarily a causation as well.
Oh, they are correlations. We do know they're correlations.
Right.
We don't necessarily know it's a causation because I mean, we do. I mean, we do biologically now, but you have to. There's different statistical methods that we haven't discussed in this course to show that to prove that.
Okay.
And the reason we don't cover it, it's not that it's beyond anybody's ability in the course. What it is typically we're not worried about that. We're looking for just some correlation. As we see
Okay.
one increase, do we see the other increase or decrease?
Okay.
Okay. Yeah. Just be very careful, please. I cannot tell you how many times I go to the talks, even in the professional level, or listening to the newspaper, or reading the New York Times, or whatever it may be, and I see this. Well, this is causing this. You don't know that. You haven't shown this. It just it blows my mind. This is why I'm gonna have a heart attack. No, I'm joking, by the way. Okay, so let's talk about this line. Well, what we've done so far is we've looked for a line, and we've kind of I haven't gone into the details, but you're looking, and at the end of these slides, there is more details about it, but I'm just providing it to in general, just in case people are curious about the mathematics. But that line, notice it's y equals mx plus b, right? We have a slope and a y-intercept. But in generic form, we could have multiple parameters, couldn't we? We have a y-intercept of that b naught. We have height. We have age. We have gender, because that line for children is dependent upon the gender of the child that they're born, the gender that the child's born with. So this is known as a multiple linear regression. So you have multiple variables: height, age, gender, and so on, to dictate what the weight of the child would be. Another good example, and please ask questions, or if you come up with an example where you have multiple parameters, is the amount of light exposure that we were doing in confounding variables, right? We found that it can't just be the child if they have ADHD or not, right? That'd be X1, but it's if the father also has ADHD as well. So what we say is, like, for example, X1 is that measurement that the child has ADHD, and X2 is if the father is the confounder by the child. And one of the nice things is if this coefficient here, if we add in this little piece, this new variable of the father in this scenario, and that new B1 from the top to the B1 with a hat on it, that's called the hat, or that's a caret, changes by more than 10%, then we usually say X2 is a confounder. I want to note, there are very, very good examples in section 9.5 and 9.6. And both of those examples are really cool because they could be related to something you might be doing in the future. They are dichotomous, so it means it's yes or no. Father has ADHD or they don't. And you have the ability to assign one or zeros to the values. I love those examples. And if we had time and if we were where we should have been in the class, we would have went through those examples. I do want to note. Oh, yeah, go ahead, Tiara. Sorry.
So, like when women get breast cancer, they have to determine if they have the Brachy gene. How did they find those the cause to having that gene, which determines if like your child will have breast cancer, right?
Yeah, actually, that's a good point. I'm hoping I get this NIH funding, and we're going to look at ways to cure that. So I wrote a grant, and we're going to be studying that using artificial intelligence and data analysis with myxobacteria. You just brought it up, so I'm just saying that. But yes, the answer is yes, that is true. That'd be like a confounding variable. Did that answer your question, or did I just go off track?
Yeah, it answered.
Okay. I do want to note that the wording that they use in their analysis in section 9.4, it's wrong. Okay, their results of the analysis is wrong. The newest edition should have the update, but I don't have the newest edition of the book. There's no such thing as the most significant variable. You can only measure significant versus non-significant. So the example in 9.5 in section 9.4, they say the most significant variable is this. No, it's not. You can never say something's the most significant. It's either significant or it is not. It's a different test. That is a totally different statistical analysis you have to do. In 9.6, example 9.6 from that section, it's important to note that at the end of the example, they discuss the relationship between continuous and dichotomous variables. It's really nice, kind of a summary to remind us that you can do this analysis of linear regression and multiple regression analysis, even with dichotomous. A lot of people think that you can only do it with continuous variables, height, weight, but you can do it with our age, but you can do it with gender, you can do it with race, so minoritized population or non-minoritized population. And then finally, these examples, I'm just trying to clarify if you ever go to the back of the book or back into the book and want to like understand this a little bit more based off of the very rough review that we're doing here, that I'm trying to fix some of the wording. Okay. And again, you can't be marginally significant. You're either significant or you're not. Um, I just want to kind of expose you a little bit here is to multiple logistic regression analysis. So when you hear the word, when you see that title, what are you thinking? Multiple logistic regression analysis.
Multiple variables?
Okay, so multiple variables. So we're like X1, X2, X3. Yeah, I agree with you, Yana. What else? So we got the multiple.
Well, in the book, it said it's used to assess association of the linear regression. I mean, to assess the association between two or more independent variables and a single continuous dependent variable.
Okay, good. I agree. What does logistic mean? So, so I want logistic think logs, logarithmic. So that's what it is. So we to be able to do with this dichotomous, as Tiara was saying, we have to use logs and exponentials. So a simple logistical analysis is you have a dichotomous outcome, yes or no, and one independent variable. Okay. Is your BMI above the overweight indicator? Yes or no? Multiple logistic analysis could be you have one dichotomous outcome, again, yes or no, and more than one independent variables. So let's say that we talk about having hypertension, right? Instead of calculating the number, we're saying, do you have hypertension or not? Do you have high blood pressure? We know that weight has a factor, age has a factor, sex has a factor, race has a factor, um, income level has a factor in having hypertension, and many more, by the way.
Mm-hmm.
So we have multiple independent variables coming in to get to yes or no, you have hypertension.
So could any of those independent variables have different weights or sign?
Yes.
Okay.
Yeah. Yeah, and those weights are based off of that beta value that we were seeing before.
Okay.
So we multiply it by something.
Mm-hmm.
Yeah, that's a great point. Because we know one of the biggest indicator is weight.
Mm-hmm.
But I believe that there's been studies that the next biggest indicator is actually socioeconomic status. Because socioeconomic status affects weight.
Yeah.
Yeah.
So can I ask a question? So if I wanted to look at um, um, income, race, education, and its impact on maternal mortality, that will be a multiple regression.
Yeah, that'd be multiple regression, but you're looking at infant mortality in what sense?
What maternal
Like,
mortality, like what's its relationship
oh, yeah,
like to
yeah,
the to
maternity. So they either die or they don't, right?
okay,
Yeah,
based on
that'd be it.
those
Yeah, go ahead. Sorry.
also like based on those different independent variables, and then the one thing that's not I don't know what I guess what I'm asking is it multiple regression because it has multiple independent variables looking the relationship to one dependent variable?
Yes,
Okay, so if I
one
wanted to
outcome.
look at the relationship like my project, the relationship between income and race, it would just be a regular linear regression.
Um,
Like what's the relationship between income and race? Well, no, because there's like multiple race.
I would still say that's because well, for your project, you're looking at maternal mortality,
Yes.
right?
Yeah.
So it's still maternal mortality that you're looking to affect.
Yes.
And you're looking at two things that are affecting it. So it's still
Yes,
multiple.
race and income. Okay,
Yeah.
gotcha.
So it's still. Okay. The formula, very complex. I apologize. There's no easy way to go about it. Remember, dichotomous is 0, 1. P is the probability that the outcome is assigned to 1. And this is what it is. I don't have a choice. This is the formula. We can rewrite this using some nice simplification, using natural logs. But look at it. Disregard the left side of this equation. What does the right side look like?
Like a generic line equation.
Yeah, right?
Yeah.
It looks like that generic line equation we were discussing before. The, the left just has that natural log of that probability. Okay. Remember, dichotomous is a probability between 0 and 1. Getting the values of B is way beyond the scope of this course. Again, I mentioned that we have a course in the math department, a graduate course called multiple regression analysis, where we spent more than half the semester just doing these type of problems. Okay. It doesn't mean you can never figure it out. You all have the ability to do that, but I just want to make sure that you recognize this is like people will present this, but a lot of times the people in public health or biology that did this work worked with statisticians. And so what does that mean? It's okay to work with statisticians. It's okay to reach out to people for help. I had a student that was in the public health program who now does research on what was it on? This was a couple years ago. Um, but it was like children getting access to Medicaid, I think it was, who but are immigrants. And they had all this data, and he's like, I did this analysis, but it doesn't seem right. It took me a long time to get to it and to analyze it, but I still was able to help out a little bit. People do this all the time. Biologists come down to my office asking me about stuff. So it's okay to ask for help. But you want to make sure you have some exposure to what their results are giving and what type of analysis you're looking for.
So, quick question.
Yes.
How do you report your analysis, whether single or multiple? Do you do like a narrative of it, or do you do both? Do you
You
have like a numeric report and a
yeah, so
narrative?
you'll have both a narrative, a paragraph where you say we did a multiple linear or logistic regression analysis. And then you'll say see table 1 for the variables and for the coefficients that were calculated. And then in discussion you interpret what those results mean.
Okay. Okay. Thank you.
Yeah, that was a good question. That's a great question. I'm gonna write that down. Sorry, it's something I'm thinking about for next time I teach this course, to give some examples. So one of the things I want to think about is, so this example says B1 is the change in the expected log odds relative to a 1 unit change in X1, holding all other variables constant. So, okay, what the hell does that mean? What it basically says, if I take the exponential of B1, right? So I take this value, this coefficient, right? This weighting term, as Chelsea was asking about, that will give us an odds ratio between of changing X1. How much does X1 affect what's going to happen to the yes or no answer? I wanted us to do some examples, but because of time and just how the semester went, we won't be able to. But again, I very rarely, in almost all my courses, I don't require students to buy a book. I don't put it as like a requirement for the course. I use open source or I give my own notes, whatever it may be. This is the one course where I really recommend keeping the book and using it. I have mentioned it so many times I use it. It's not me praising the book. The book has problems. It has mistakes, but it has
Professor,
enough of the information. Yeah, go ahead.
what time we getting out of class today?
At our regular time.
How come we wouldn't have time? It's only 7:50.
What?
How come we wouldn't have time to do an example? It's 7:50.
Because I want to get to one other topic.
Okay.
I'm sorry. I mean, I have one here. Um, but I think it's just I want to get to the next piece, but yeah. Sorry. I'm really sorry. So please forgive me. At any point, as a student or as an alum, you want to come and talk to me and talk about statistics or whatever, my door is open. Okay. Obviously, my priority goes to the students I have currently, but it doesn't mean we can't meet and talk. And many of them have done that before. And my point is like, I don't know if other faculty have told you that, but it's not just you being an alum or just a current student, but it's to recognize like you're looking out for help. People do this all the time to faculty and professors. They email us stuff. Okay. So if somebody like curious about like some random thing that they see in data all the time, and they send me an email once every month. What do you think about this? It doesn't mean I can help right away, but it is still, we're here as a guidance, okay? Okay. Sorry. That was a big run through of a, I don't think it's too complex. I think many of you probably got it, but I think the calculation, if you had to sit down and do the calculation, you wouldn't be able to do it. But that's not my goal for this part right here. It's not for you to be able to do it, but for you to be able to interpret and understand what's being given to you. Okay? And again, the big piece is causation does not mean correlation. I will post these slides. It does have some examples that I did, and it also has some more talk about the calculations, okay? And you have access to all this information. Okay. What I want to be talking about next is known as non-parametric test. So, and the reason I want to get to this is I find it the most interesting topic that we do in this semester. So what we've done so far is like one of the biggest units that we did was hypothesis testing. And we discussed what that means is we're checking the significance between two variables. So for mean and difference, we did t-test or z-test. For multiple mean comparison, ANOVA. For proportion, t-test or z-test. And proportion or categorical test, we did chi-squared. But each of these tests had assumptions about what's going on. And so one of the things is we assumed that the data followed a normal distribution. And to do that, we had to take into account that the central limit theorem, which if n is large, it follows a normal distribution on average, or that we had to normalize the data to get it to follow a normal distribution. For a non-parametric test, what if your sample is small? What if it's 5? You're working with 5 individuals that have cystic fibrosis. Cystic fibrosis is not very common. And we don't know what the distribution is for those people experience a certain type of pain. So we can't assume anything of if the pain management follows a normal distribution. So my sample size is small, and we can't assume it's a normal distribution. And this is known as a distribution-free test. Everything else before was assuming a nice bell-shaped curve. Height follows a bell-shaped curve. Yeah, go ahead.
Oh, I'm just listening.
Yeah. I want to recognize that these are not very powerful. So what does that mean? When we do a power analysis, it's going to tell us that we have to have a large N. And one of the questions is, how do I know if data follows a normal distribution? Well, if you have large enough sample size, you just assume it. Okay.
So I know we have. I have a question. I know we
Yeah,
have like
please.
the greater than 30, less than 30. So at what point do we determine that the sample size is too small? Like less than 20, 15?
No, it would be it's or, right? So if your sample size is like less than 10, okay? If you're unsure, then it doesn't hurt to do a non-parametric test. Um, like I said, I was using example 5, but like in that case, I would be doing a different test just in case. If you can't assume a normal distribution, so let's say we're looking at grades in a classroom. Grades in a classroom typically don't follow normal distribution. So if I want to do a test on a grades in classroom and some analysis, it'd be very disingenuous for me to do a parametric test.
Regardless of how big the
It didn't
sample
matter
size
how
is.
big it is. Yeah. Other question? Okay. That's a really good question, actually. To test for normal distribution, if something follows a normal distribution, there's a few tests. There's the Kolmogorov-Smirnov test is like the most famous one. Anderson-Darling test, and I think a couple of you saw Shapiro and Wilk test in some of your papers. Or the Kolmogorov-Smirnov. But I personally use the Kolmogorov-Smirnov test in my analysis if I'm working at a small sample size or if it's a sample size that doesn't follow normal distribution, like working with student populations. So to test it, if it's normal distribution, you do a hypothesis test. That's what a test is. State your null, right? Data follows a normal distribution. It does not follow a normal distribution. And if my p-value is less than the data does not follow a normal distribution. It can be subject to a low power. So that means that we have to worry about not only alpha, but beta. But again, that's not usually the issue. Nobody's ever going to ask you, right? what the problem is, like if it's what the low power is. If they do say, I have to talk to a statistician, which is honest. And if you ask me, I'm like, I don't know. Give me like 6 months and I figure it out. So let's think of things that don't follow normal distribution, or maybe they things that do. So they have some examples in the book, but what do we say? How much you spend at a gas pump? Does that follow a normal distribution?
No.
Why not?
I'm thinking because things that are natural to the human beings become normally distributed, and things are not normal distributed. Like that's not a like we know height, weight, those things are natural. They'll fall in normal distribution.
Okay. Okay.
And I'm also
Wouldn't it
thinking,
depend?
like,
Oh, sorry.
oh, go ahead, Benita.
No, I was just gonna say, wouldn't it depend on, I guess, gas prices? Because we've had fluctuation in gas
Mm.
prices, so that wouldn't necessarily follow a normal distribution.
Okay.
And even where you are getting the gas, a, a family trip to San Francisco, a gas was much higher there than like $12 a gallon in the during the pandemic
Wow.
than it is here, like or when I go off to Michigan.
And
Yeah.
and the type of car too.
Yeah.
Depends on the gas tank, how big the gas
Right.
tank is. If most people have SUVs and less people have compact
Mm.
cars or really super big trucks, perhaps it'll fall in normal distribution.
Yeah.
Yeah, so like wouldn't there just be too many variables? Because I'm also thinking socioeconomic status, like, at $50 to fill your tank, how often are people filling their tank or just putting in $5 a gallon or two or to get their
Yeah.
to
I
get
mean,
to
these
their
are all
work.
things you have to think about.
Yeah.
These are opening thoughts. How about access to affordable healthcare
Yeah.
or access to a CEO of sorry, too soon. Yes, no.
I would think that'd have normal distribution.
Okay. Income level.
No, not normal distribution because we'd have to figure out what percentage of individuals fall under like the poverty line and how many are exceeding the amount of money that the average have. And that
Mm.
those don't
Yeah.
seem like it'll be a normal distribution.
Yeah, it's called for income, I know for a fact it's called the Poisson distribution. Okay. Yeah, it doesn't because you have people that make billions of dollars.
Yeah, oh yeah.
Yeah, and you have an end where people make zero, right? So it's how about education level?
Hmm.
Perhaps there'll be more people on the less educated side, on the lower side with the educational attainment, and maybe more people who are less educated and less people who are highly educated. So probably be leaning over to the right a little bit more.
What percentage of Americans have bachelor's degrees?
Oh, I have no idea.
Well,
That's a
well, in
question.
Illinois, I know it's 22%.
22%?
Dang, you pulled that out. Of
I think
Yeah,
adults, right? It's
like
adults, isn't it, Tiara?
40.
yeah, it's adult.
So Alex said 40. So let me look it up for us. What percentage of American adults have master's degrees? It's obviously less than our other number.
In
Uh,
2022, 23.5%.
Americans or Illinois?
Uh, Americans.
Have bachelor's?
Oh, wait. I'm
But
sorry,
after this,
37.5.
yeah, that's
I
what I was
got 14. I swear I got 14.
Yeah, where you see, I
Put
think
it in the
Alex,
chat. Put it into the chat. Your reference. Alex, put in yours too because you caught it. Your guys are pretty good.
Yeah, Chelsea's one seems legit.
In 2022, it's 37.7%. 25 and older had a bachelor's degree.
Yeah. So, how about masters?
14%.
That's what Tiara had, right?
Oh
Yeah.
yeah, that's what I got from masters. Yeah, I got 14.3%.
So, by the way, we're gonna pause here for a second, and I want to say, those that are graduating, congratulations.
Yeah, congratulations.
Like that's a
Thank you.
huge deal. And I always tell this to my undergrad students is I give value much more to my bachelor's degree than to my PhD degree because it was, the attainment of it, the amount of effort, and I knew nobody was going to be able to take it away from me. One time I obtained something that I knew somebody could not take away from me was that degree because I earned it. And I want you to realize like all the effort and time, those that are graduating, um, the amount of work that you've done. And not only that, those of you that are getting a master's, the amount of work that you've done to get even here. And you should, sometimes it's really good to reflect like, it's been hard, it's been rough, I've made some stumbles, I've had some issues, but you should be very proud of yourselves. Okay? Yeah, smell the roses. I really think it's important. Like, I was proud of my PhD, I still am, but I'm much more proud of my bachelor's degree. So so congratulations. Who's graduating, by the way, if you're willing to share?
I'm graduating in 10 days.
Congratulations. I'm sorry I won't be. I
Congratulations.
usually go to the ceremony, but I don't. Who else?
Thank you.
I'm also graduating.
Congratulations,
Thank
Amaya.
you.
I'm
Congrats, Hannah.
so proud of you both, and you should be proud of
Thank you,
yourselves
Samaya. You
too.
too.
Thanks.
So if you see them at any point or have their contact, you should send congratulations and be happy for them.
Mm-hmm.
So and okay. Because not many people get these degrees, and you're in education, and you're guys in academia right now. You're like, well, everybody's getting a bachelor's degree. Then people go on to masters. That's not necessarily true. Okay. So, what is this non-parametric test? What happens is we have different types of variables, like we've done before. We have dichotomous variables where we have the yes or no, categorical data, right? We're ordering people into groups, and then continuous. We also want to talk about ranked values and how to take care of that. Think about pain measures in a doctor's office, right? So you go to the doctor's office, what's your pain level? Is that what it's called, APGAR?
No, that's for infants. I was just reading what the book said. The book said the APGAR test is a ranking test.
Oh yeah,
Based,
yeah.
yeah, the criteria for
What's
infants.
up with the vest?
What are you saying, Alex?
Oh, yeah, then you're trying to make stuff. Sorry, my mic was off.
No, that's okay. Yeah. Um, so let's think about ranked measurements. So the way the procedure works is it's the same as it's always been. You have this five-step process. We're going to set up a hypothesis, select the value of significance, select the appropriate test, decision rule, compute test statistic, and conclusion and p-value. There's a reason we started this five-step process. I have a PhD. I do research with statistics. I still do this. I have to do it. And I promise it helps. So really think about it. It doesn't mean that's what I'm presenting as the 5 steps, but I have it on my pen and paper when I'm trying to analyze and organize my information, my thoughts. The test will kind of go through, and the book has, is the Mann-Whitney U test. So this is when you're comparing continuous outcomes in 2 independent samples. The sign test, compare continuous outcomes in 2 matched or paired samples. The Wilcoxon signed rank test, compare continuous outcomes in 2 matched or paired samples. So the sign test and the Wilcoxon signed rank test, they're very similar. And then the Kruskal-Wallis test. This is where you compare continuous outcomes in more than 2 independent samples. So think ANOVA, basically. So these are the tests that for continuous. Okay. So what we'll do is we'll take another 5-minute break. Do you guys need a 5-minute break? Stretch your legs.
Yes.
Okay. Okay. 5 minutes. Let's get back at 8:12 and we'll go through some examples with this. Okay. Let me know when you're all back.
I'm back.
I'm
Thanks,
back.
Chelsea. Thank you. Sorry, I'm trying to scarf some down some dinner. All right. Got 4 of you. So let's do an example. And this comes from the book, page 247. And what we're going to do is we're going to say, well, somebody want to read it for us, actually? That'd be better. I can eat a few more bites.
It's on page 247.
Yeah, that is correct.
I'm on page 247.
Oh, yeah, 247 at the very top. A small study.
Okay. A small study, n equals 10, is designed to assess whether there is an association between smoking in pregnancy and low birth weight. Low birth weight babies are those born weighing less than 5.5 pounds. The following data represents the birth weights in pounds of babies born to mothers who reported smoking in pregnancy and to those who did not. Go on.
So, yeah, keep going.
Okay. So the mothers who smoked during pregnancy,
Oh, you don't have to give the table. You don't have to
okay.
give the data.
So is there a significant difference in birth weights between mothers who smoked during pregnancy and those who did not? Run the appropriate test at a 5% level of significance.
So notice the data is small, isn't it? We only have 10.
Yeah.
You can imagine doing this in a small clinic. And you're just curious what's going on. You, as an individual, are a public health individual, and you see this, and you're like, I wonder if there's a difference.
Mm-hmm.
We know we don't want them to do it because of other reasons, but does it also affecting birth weight? That is a legitimate question.
Mm-hmm.
So we have this data, and you have to choose the right test. And because the N is so small, it has to be a non-parametric test. And we go up here, and we see what our options were. And we want to choose, we have either a sign test or Wilcoxon signed rank test because it's continuous and they're matched or paired samples.
Mm-hmm.
Okay. But it's not really, but they're not matched, are they?
No, they're dependent.
Yeah, they're independent, independent. So maybe we should be doing a Whitney U test. Okay. Because it's comparing continuous sound in 2 independent samples. So I see this, I'm like, okay, that's what we're going to do. That's our test. I'm sorry, I really have to eat.
Mm-hmm.
So we go through our process. 2 populations are equal. The weight will be equal. It will not be like they'll be unequal. And then we say what we're going to be using, the Mann-Whitney U test. Well, we can use the appendix where it tells us what the value for U will be. Since we call it the U test, it's U. And we set up a decision rule based on our population size.
Mm-hmm.
And it says we will reject the null if U is less than or equal to 2. And we can calculate U. But I don't want to do that. And you don't want to do it either. And you can actually do this in R. And you create your 2 variables and you tell it to do a Wilcox test. And it'll give you the value. And what does it say? The alternative hypothesis, true location shift is not equal to 0. What is the p-value? Is it bigger than 0.5 or less or smaller?
The p-value that we see on the screen is slightly larger than
Slightly larger. No, it's just slightly.
yeah,
It's
yeah.
almost exactly the 0.5, but it's still slightly larger.
Mm-hmm.
Okay. So we say we going to accept the null or reject the null?
Wait, can you go back to what the null hypothesis is?
Mhm.
We accept it.
Yeah.
Mm-hmm.
We do not have statistically to show that the two population weights are equal. Okay. So yeah, we accept it. There's two negatives in that statement, by the way. However, we have low power since the population is small. That is okay. We're doing it for our clinic.
Mm-hmm.
I do want to mention that in R, the Wilcox test does multiple types of non-parametric tests. So it does the Mann-Whitney, the U test. Okay. So I bring up this point is these non-parametric tests are really good if you're working with small populations.
Mm-hmm.
And all I can think about is myself trying to do some data analysis for free for a clinic that's working with, you know, um, in a rural area or something like that. Let's do another example. Anybody want to read what this is? This is page 246, number one.
A company is evaluating the impact of a wellness program offered on site as a means of reducing employee sick days. A total of 8 employees agree to participate in the evaluation, which lasts 12 weeks. Their sick days in the 12 months prior to the start of the wellness program and again over the 12 months after the completion of the program are recorded and shown in table 10-24. Is there a significant reduction in the number of sick days taken after completing the wellness program? Use the sign test at a 5% level of significance.
Yeah. So a company comes to me and says, we want to know if we're going to save money on paying for sick days if we implement this wellness program. It's a good question. Many companies have been asking that for a long time. They do it, and this is the result. Again, let's go step by step.
Mm-hmm.
The median difference is 0, is the null, so there is no difference. The alternative is there is a difference, and we were looking for negative this time because we want to see a decrease in sick leave. They say do the sign test. The sign test says that is basically we're testing is there positive or negative. The decision rule, the smaller number of the positive or negative signs is greater than equal to the critical value. Since we're doing one-sided and there's 8 people involved in this study, then the critical value is 1. Calculating the sign value in R is doable via a bunch of packages, but let's just do it by hand. And by hand, you're going to see this is nice and easy, nice and straightforward. Notice that the 6 days, we're going to look at the difference between 6 days prior and 6 days during this intervention.
Mm-hmm.
So we're going to take the difference between during and past. So we're going to go during minus past because we want to understand is the during this intervention effect giving us a good outcome or negative outcome. So you take the difference. You say minus 0. And all we're doing is notice I'm just giving you the difference. And then we're looking at the sign negative, positive, negative, negative, negative. The number of positives is 1 and the number of negatives is 6. So we're just looking at the sign. Doesn't matter if it's 11 or 12. We're just looking for a decrease. Since the smallest of the two is the positive one, then the test statistic value is 1. However, since we can only use 7 values, we should have been comparing to 0. So what I mean by that is if you look at the what the value we should be comparing in the sign, um, and I'll give you the page number for this too. So if those that have their book. So if you look at table 6 on page 346, it gives you critical values for the sign test. And our n here is not, here we have 8 points, so it looks like our n should be 7, right? Our degrees of freedom should be 7.
Mm-hmm.
But it's not 7 because we can't include the 2 value right here. Because there's no difference. So instead of degrees of freedom, since we want to compare it to 7, we want to compare it to actually 6. Of degrees of freedom is 6. And since that value of the test statistic is 1, and we want that to be greater than 0, we do not reject the null hypothesis.
Mm-hmm.
Therefore, there is a difference in the amount of time spent on sick leave with the intervention. And to get that p-value, it's a binomial calculation. It's beyond the scope of this course. But I give it here for completion. But look how easy this is. You're just looking at pluses and minuses. That's it. Again, low power though. Small sample size. All right, example 2, page 246. Somebody new. Somebody who's gonna read for us, please.
I can go.
Yeah, go
Using
ahead.
the
Thanks,
data
Samaya.
and using the data in problem 1, assess whether there is a significant reduction in the number of sick days taken after completing the wellness program using the Wilcoxon signed rank test at a 5% level of significance.
So what we're doing is we saw before that there was a significant difference, but now we want to do something maybe a little bit different, not just look at positive or negative. So the Wilcoxon sign rate test is a little bit more involved. So what we have is set up our hypothesis, meeting the null is the median and difference is 0. The alternative is negative. So we see a decrease in sick leave. Step 2, we say we're doing this test and divide, and it's defined as the smaller of W plus and W minus. Again, this is wording from the book. I don't worry about it too much because we're going to do it using R. And we reject the null if the W is above some critical value of 6. And that critical value we can see in table, I think it's table 7. Okay. So we say our N, the sample size is 8, and we want 0.05 because it's one-sided, and we want the critical value to be bigger than 6. Again, we can do it in R, and notice what it's going to do. We're going to say it's Wilcoxon test, same as we did for the Whitney Mann U test, Whitney U test. It's the same thing. Wilcox.test is just the non-parametric testing in R. All the same thing is good, but one of the things we want to do is we want to have this word paired is true. And what we're saying is the data is paired. So this person, employee 1, We're looking at their 6 days prior and their sick days during this intervention. We run this, and one of the things, you're going to get an error. And you're going to get an error because this value for patient 2 or employee 2 is the same. So you want to take any values that are the same. And you should be asking yourself, wait a second, you told us never to get rid of data, right? Never get rid of outliers, right? I agree. And you have to be very honest with yourself. And if you notice that 5 of the 10 people didn't see any difference, then maybe we should be doing a different test that's not discussed in this course. And or you're going to say those that saw a difference in their amount of sick days saw a decrease, statistically significant decrease. And those that didn't see any difference at all. So you have to be very honest. Don't lie about the data. Okay. They give a V value. We call the W in the book. They give a P value. And the P value is definitely less than 0.05. As before, we have to disregard the data for the same value. So our criteria changes to W is greater than or equal to 4. Since W is huge, is much bigger, we can reject the null hypothesis, and thus we have statistically significance that there's a decrease in the amount of sick days. If I look at this plot, it is not apparent to me that we will see a statistically significant. I see a couple, but is that enough days? Anybody work for a company that has these type of interventions?
I don't, and I don't think that my coworkers would respond well to such a program.
You're like, we're just trying to survive.
No, really, we're all a bunch of social workers. Yeah.
Yeah. Your life is already stressed enough. Anybody else? No, no, yeah. I'm just curious. Hold on, Tiara, don't you work at the LSC?
Yeah, I do.
Don't you have like, isn't this like the week for anti-stress week?
Yeah, but
You know, you can use it
I
too.
oh
I believe you can. Don't quote me on that.
yeah, I know it's anti-stress week, but yeah, I didn't use any other services. But in Dr. Bennett's mental health class, he do talk about how certain jobs since the pandemic incorporate um resources for mental health for the employees. That's the
Yeah,
intervention.
yeah. It's just interesting. So if I'm a small company and I want to intervene, I want to try this. This is a good way to test it. Okay. Who wants to read number 4? Somebody new. And I will be honest with you, this one took me a little bit to do myself.
How long did it take?
I don't know, 30 minutes. Is that relevant?
Yeah, because I'm trying to compare it to how long it takes me to do my homework. That's why I asked.
Nah, you'll be fine.
It takes me about 3 days to do my homework.
Oh my God, I'm not alone. It takes me
No,
that
you're
long.
No,
A
no.
short problem takes me like an
The
hour.
whole day.
Yeah, yeah, it's
Nobody's answering my question. Who's gonna read it?
I don't mind reading again if need be.
That's fine. All right.
Okay.
Yeah, go ahead.
4. The following data represent the number of playground injuries occurring among children aged 5 to 9 years over a 3-month period in 12 playgrounds in and around the neighborhoods of Boston. Playground injuries include fractures, internal injuries, lacerations, and dislocations. Holy Moses. The question of interest is whether there are differences in the numbers of injuries at playgrounds in various locations. The data below represents the numbers of injuries recorded at 4 randomly selected playgrounds located on school properties, at daycare centers, and in residential neighborhoods. Run the appropriate test at a 5% level of significance.
Yeah, so what we're looking at is we have just, you know, we have school, daycare, residential. And what I've done here is I've kind of compiled this into this nice table. So what we're going to be doing is we're going to be doing this Kruskal-Wallis test, and this allows us to do it. It's like the ANOVA for non-parametric test.
Hmm.
And so the question is the median and all, notice it's not average, by the way, it's median, not mean. Okay. The
Okay.
median, and this has been true for all of them. I meant to like highlight it every time. The median in all locations is the same. The median in all locations not the same for the alternative.
Mhm.
And we have this nasty, nasty calculation for the Mann-Whitney U test. Or sorry, that should be Kruskal-Wallis test. I'm not going to do that. Are you going to do that? No. The answer is no, Dr. Ibsen. No, we are not going to do this. Okay. We want to set up the decision rule. Again, it's based off Appendix Table A. And it follows the same procedure. We're going to calculate this using R. And you know what it's called? It's called the Kruskal dot test. Okay. And what you do is you want to create each of those values, but you want to actually give them labels: school, daycare, and residential. And it just helps to do it this way.
Mhm.
And what we see is we get a Kruskal-Wallis chi-squared is what it's called, but they don't call it that in the book, of 7.883 and a p-value that is less than 0.05. Okay. I want you to notice all these tests we're doing in R. Want to know why? The calculations are stupidly complex, except for the sign test,
Mhm.
sign rank test. And I'll tell you something, doing them in Excel is also very complicated. I can never get them to work in Excel. This is where the power of R does come in, unfortunately. Okay. So the conclusion is, since the H value is greater than our criteria, we reject the null hypothesis. We have statistically significant data to show that there is a difference in the amount of injuries between the 3 locations, but we don't know which one. You can look at the data, you're like, oh yeah, I'm gonna see a lot smaller amount of injuries at the residential neighborhoods. I can say that, but we don't know if it's statistically significant. We just know between all 3. Just like with the ANOVA. I cannot tell you how many times I see people writing a paper, presenting results, and say there's a significant difference in this one group when they did a ANOVA. Almost nobody does a Kruskal test. Bonita, you're killing me. You're killing me, Bonita. So one of the things I want to remark on is that we're using non-parametric tests to do a hypothesis that has small sample size in which we cannot assume a normal distribution. You can't assume a normal distribution on the amount of injuries that you see at different types of parks. I know I can't assume a normal distribution if my N is only 5, right? 5 pregnant women that smoke and 5 that don't smoke. I know for a fact I can't do that. But we have to do something. We have to try to do some analysis and convince those that out there that are the decision makers to invest or make this make different policies or whatever it may be. Um, I want to also recognize that we've only skimmed the surface. We have a whole course in the graduate program in the math department that's nonlinear regression analysis. Okay. And we spent some time on this non-parametric test and nonlinear regression analysis. By the way, I just wanted to show you by hand what the Wilcoxon signed rank test is. I got so frustrated. I was like, I want to figure out how to do this by hand. And so I end the notes here by like talking about the sum of the positives and the negatives. It was just me being a perfectionist and trying to figure that out. Okay. This is a whirlwind that we just went through. Okay. So let's kind of recap a little bit what we've done here. We talked about confounding variables. Then we went in we said, now can we figure out linear regression analysis, correlation between two different variables, bivariate. They said, well, can we introduce this concept of this confounding variable, and that would give us multiple linear regression analysis. And then we said, well, what if I'm working with dichotomous output? Yes or no? And we have multiple inputs for if you have hypertension or not. And that was multiple linear regression analysis or multiple logistic regression analysis. So what we're looking for is the effect on different variables there. For non-parametric tests, it's us coming back to our roots of hypothesis testing and recognizing what happens if I have a small sample size. What happens if I look at the data and it doesn't follow a bell-shaped curve? How do I deal with that? And the whole point is the whole point of these last two pieces here, non-parametric and the linear regression and multivariate regression analysis, is to be exposed to it. So if somebody tries to pull something over you and says, hey, we did a study for your work, for your company of 10 employees or where you're working, or for, I'm looking at Chelsea because you're shaking your head, like 10 people that are homeless, and we did this survey. And we show that there's statistically significant difference in the reason that they're homeless or whatever it may be. I can't think of something off the top of my head. You should be asking the question is, how did they do that? I will almost guarantee they did not do these type of tests.
I have a
Doesn't mean they're
question. So
wrong. Go ahead, Tiara.
when it comes to like sample sizes, you know how like on like supplements and they say it's been clinically proven, would that be like an example of like data that isn't accurate because like who are you testing like and what's the sample size? Because like a lot of I
Right.
guess weight loss supplements like it's
Mhm.
guaranteed to
Yeah, my favorite. Yeah, I definitely agree with that. One of my favorites is like 4 and 5 dentists approve this medicine
Mhm.
or approve this whatever. Yeah, 4 of those dentists say this is toothpaste. That's what the approval means. Is
yeah
4 or 5 a lot? Did they just ask 5?
Right.
The supplement stuff is that's going down a rabbit hole, right? Because it's not regulated and it can be very dangerous, and people rely way too much on it. And a lot of times they will only test it on a very small population that's very particular.
Mhm.
So like, yeah, it causes weight loss. One of my favorite examples is um, this company said they did an intervention for to see if they would see better health outcomes for their employees by asking the employees or giving an incentive for employees to go for a walk every day after lunch. The people that there's a bias there, right? The people that took
Mm-hmm.
advantage of that were typically the employees that already wanted to go for a walk. They're like, yeah, I'm going to take this,
Mm-hmm.
right? And so they weren't seeing any change in health outcomes because they were already doing that walk anyways. But we see this for supplements all the time, Tiara, all the time.
Yeah.
Be very cautious. Again, this is not a political statement. This is just it's a cautionary tale
Mm-hmm.
and be
Yeah,
questioning.
I know that. Yeah, yeah.
Well, I keep thinking now, like, so what's the difference with it, such small data samples and just compelling anecdotes? Um, I don't know, for my agency, we recently had, we have a yearly fundraiser and we always have the big story. Um, and I guess now, like, my mind is I go for the anecdotes. I like them. I like the, but now I'm like, oh, they don't mean anything unless
No,
there's
no, no,
the
no.
numbers
Please
behind.
never
But if
say
there you have
that.
numbers behind them, okay, go ahead.
No, 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 no. So one of the things is anecdotes are good.
Mm-hmm.
There's a thing called data storytelling. Has anybody heard of data storytelling?
Mm-mm.
So it's where you're
No,
collecting data on a, oh, go ahead, sorry.
I just said no.
So it's where we collect data on a population.
Yeah.
But what happens is we ask for qualitative or
Mm-hmm.
stories related to that data. That's that anecdote. So if you
Okay.
have both, if you both
Right.
have that anecdote, that's that strong story that's very compelling, but also the
Mm-hmm.
data behind it for a larger side of the population
Mm-hmm.
together, that's
Yeah.
compelling.
Yeah.
Anecdotes are not bad. I will go to my colleagues and say, I have heard from a couple students that they would like to take a certain course that's not being offered. That's
Mm-hmm.
anecdotal. If I want to actually have the data, I have to do analysis of all the majors.
Yeah.
Okay.
No,
So
this
don't
is
move
it.
away from anecdotes.
Okay. Yeah. No, this is interesting because I'm thinking about my post for the final discussion, and I'm going to be talking about how important data is for what I do and connecting people to housing rental subsidies, um,
Mhm.
and looking at the state of homelessness in 2024 put out by the National Alliance to End Homelessness. It's like record number of people who are experiencing homelessness for the first time. Severe housing cost burden is on the rise. And it's interesting because I can think anecdotally, like this is happening within our agency where many more families. Anyway, so yeah, so I could thanks. This is I'm excited that our agency is using data more and our region is using data more. It's helpful.
Yeah, Tiara asked a good question about how we define certain things. That's another thing we have to be
Mhm.
cautious about. Yeah, when we're talking about unhoused individuals, homelessness has a variation, right? There's temporary
There's
versus, I mean, you would know more about this, Chelsea, than I would,
Yeah,
but
HUD defines four categories of
yeah,
homelessness: absolutely unsheltered. I mean, it's a whole. And there's also special populations, transition aged youth, families. I'm
yeah.
going to put a bunch of links in my discussion post.
Yeah,
Uh,
please get these discussions out, by the way, because one of the things is you want to share with people where you might be. So, for
yeah.
example, I know like let's say that at some point you're out in your careers, like you're like,
Mhm.
hey, I you want to change jobs and you want to do something more related to homelessness and helping with that. I know somebody. I know Chelsea. Let me get you
Yeah.
in contact with them over there.
Yeah. Yeah.
And this seems trivial to all, maybe a lot of you, but the networking piece of this is very important. So speaking of anecdotals, one of the things in my other class I always ask, you guys have been getting the graphs and what these graphs are. Okay. I'm sorry that we had a pause for a bit. It's just I was sick and I had a hard time creating stuff and um but they were getting questions like philosophical questions. And one of those like, what's the best type of pizza? Um, this weird, random, stupid stuff. But one of the questions today, and we hadn't done it for a long time, was, is college worth it? My question to them. And it was interesting. These are undergrad students, and they all said yes, and they're all there doing it. Many of them returning non-traditional students. It's in EIU. And a few of them said, it's worth it. But one of the big things, it's not just about the courses and the major, it's also about us connecting with people. These were my most quiet students. And they recognize that. And you think in a graduate program where a lot of the courses are virtual and you don't have this sense of community, some of you do. I do want to reiterate that they're right, even for graduate. I know everybody that was in my cohort for grad school where they are right now. And I'm in connection with some of them. Some of them I'm not, but it's okay. But I know that like I've had students connect with them. Yeah, I really miss in person, big time. This class, by the way, used to be in person back in the day. Just so you all know.
Yeah.
And I think that's really important. So the reason this last post, it's a little bit related to what we've been doing in class, but I really is for you guys to know that there are other people out there doing something maybe that you have an interest in and you connect with. Or down the line, you have a friend that is interested in this certain area. Let me connect with that. Okay? So I hope I leave the class on a good note with that. I am very excited to hear your presentations. You've all improved dramatically on your presenting skills. Take the advice I've given on project 2 and improve from there. We can meet next week, but find the time. All right, everybody.
Thank you
It's
so
very
much.
nice to meet you, everybody. And I'm really sorry about this semester. I really feel bad about it wasn't as smooth as I wanted to, but I really enjoyed meeting all of you.
All right, good night.
Thank you. Dr. Hipton, would you be replying to any emails over the weekend? I know obviously, your hours are next week.
Yeah, my email for this weekend is going to be a little hard, but I will try.
Okay.
I'm usually pretty
Okay.
good, but you'll still get the weekly email like you always do.
Okay.
It just with everything that's going on, it's a little bit more difficult. But yeah, so you can always send it to this weekend. Don't worry about it if I reply or not, in some sense, and then you can say send a follow-up Monday morning.
Okay.
Okay.
And just to piggyback off of something you said, Dr. Hibden, if you guys have any like suggestions as you're wrapping up your presentations and you want to post in the community discussion board this weekend, I think this is probably going to be the best time, helpful. Anybody who want to exchange some ideas and notes, please feel free to drop it in there. I know we're all going to be busy, but I just wanted to throw that out there.
Also, you can practice with each other.
Perfect. Yeah.
Thanks, Bonita. That was really good.
Will do. Thank you.
I just have one more question. So when we actually download our presentation,
you don't have to download it.
Oh, we don't have to submit it?
Nope, just the report.
Oh, just the report. Oh, okay, great. All right, thank you.
You're welcome.
Thank you. Bye, everybody.
Bye, everyone.
Thank you. Bye, everyone.